Hello everyone, in this video I'm going to be going over how to write a direct proof for this statement right here. So the first thing when you want to write a proof, or a direct proof specifically, is you want to turn this statement into its if-then form. So you'd want to write suppose, and then the if part of the if-then form. Sometimes the statement isn't in if-then form. In this case, it is in if-then form, so that takes a step away. You don't have to do that extra step, but you would want to turn the statement into if-then form if it's not already. So you would want to write suppose first, and then the if part. So suppose m is even. Then you want to define all of the definitions that not everyone knows about. So in this case, what does even mean? Well, we have the definition right here. So if you have a number and it could be represented in the form of 2 times some integer, then that number is even. So now, what you want to do is address that. So you'd say, by the definition of even, m equals 2 times k, where k is an element of the set of integers. So now you have this definition down. Now look here. We're trying to prove that 3m plus 5 is odd if m is even. So we know that we're going to have to encounter what odd means eventually, because we're trying to prove that 3m plus 5 is odd. So what you want to do is you'd want to look at the definition of odd. It says here, a number is odd when there exists an integer k such that n equals 2k plus 1. So we don't have to say the definition of odd right away, but just keep this in mind. Let's introduce 3m plus 5 now. So then 3m plus 5 equals 3 times m, and we know that m is equal to 2k. So 3 times 2k plus 5. And that equals 6k plus 5. And that equals 2 times 3k. Alright, so now we know that 3m plus 5 is equal to 2 times some integer plus 1, because we're trying to prove that 3m plus 5 is odd, so we know that somehow 3m plus 5 has to have the format of 2 times some integer plus 1. How do we write that? How do we put 6k plus 5 into the format of 2 times some integer plus 1? Well, we know that 6k plus 5 is equal to 2 times some integer plus 1. So if we subtract 1 from 5, we get 6k plus 4 plus 1. So now we could factor out a 2 for this guy. So now it's 2 times 3k, which is 6k, plus 2, because 2 times 2 is 4, and then plus 1. So we know that 3k plus 2 is an element of the integers, because integers are closed under multiplication and addition. Meaning, if I multiply integers together, 3 times an integer creates integers. If I add an integer with another integer, that creates integers. So remember that integers are closed under multiplication, addition, and subtraction. However, they are not closed under division, meaning if you divide integers together, they do not always create integers. Sometimes they do, but not always, and therefore integers are not closed under division. So now you could say, let r equal, and then 3k plus 2, We're replacing 3k plus 2 with r. So that means, this means 3m plus 5 equals 2r plus 1, where r is an element of the set of integers. What does that mean? Well, that means 3m plus 5 is odd. So we could say this means 3m plus 5 equals 2r plus 1, where r is an element of the set of integers, which is the definition of odd. Thus, and then we write the then part of the if-then sentence, because we just proved it. We proved that 3m plus 5 is odd. Thus, 3m plus 5 is odd. And then you could put a little symbol right here to indicate that you're done with this proof.